Hi and Assalamualaikum, my name is FARAH NAZIHAH binti ZAHARI, and in this video I am going to talk about my review paper titled Sources and Properties of Halal Gelatine and its Application in Food, a Review. So, what is gelatin? Gelatin is one of the most common types of biopolymer that is widely used in food, pharmaceutical and cosmetic industries. Gelatin is made by selectively hydrolyzing collagen, where the main protein can be found in the animal's skin, hides, white connective tissues, and bones. Generally, the extensively used ingredient to produce gelatin for processed foods are derived from pig. So, what are the issues regarding gelatin and the significance of study? Porcine gelatin is commonly used over bovine due to its cheaper price and shorter production time, in which porcine only take up to 30 days and bovine can take up to 60 to 80 days. Fraudulent activities were done by food business operators to maximize profits, such as mislabeling of non-halal meat as halal purposely, or any interactions of halal meat with non-halal meat such as pork or its derivatives. Jewish and Muslims are facing a big issue due to the status of ingredients used and the unfulfillment of religious requirements in terms of the production process. So, for the significance of study, it is most important to develop a quick and strong method to differentiate different types of halal gelatin if they are derived from various sources, including porcine, bovine, and fish. Due to the rising number of Muslim consumers worldwide, the need of having halal products in terms of pharmaceutical, cosmetics, and processed food increases, especially regarding the usage of gelatin. In 2050, 2.1 million of the Islam population will outnumber any other religious groups, including Christians. So, the objectives of study of my review paper are to identify halal sources of gelatin, to determine the type of food products that involves gelatin, and to investigate the properties of each source of gelatin. Next, what are the concepts of halal and haram in Islam? Halal, which refers to anything that is permissible and legal under the religion, whereas haram refers to something that is impermissible and penal under the Islamic law. The concept of halal and haram can also be studied from the Quran and Sunnah. Main highlight of Quran and Sunnah: moral halal and haram, which are directly related to public rights, hak adami or hak fard, whereas the halal and haram material are Allah's right, hakullah. Now let's move on to the next subtopic, which is halal sources of gelatin. There are 5 halal sources of gelatin that I have reviewed in this paper, which are bovine, fish, chicken, goat or sheep, and snail. So these are some of the authentication methods used in the papers that I have reviewed. And the extraction methods used for the gelatin are acid pretreatment, alkaline pretreatment, and enzyme pretreatment. So for bovine, according to Pradini et al., FTIR with QCM sensor modification method is used for differentiation between bovine and porcine gelatin. Next up, STS pitch or sodium dosadyl sulfate gel electrophoresis is used to differentiate between bovine and porcine gelatin according to Yap and Gam. And the last one, FTIR ATR or attenuated total reflectance spectroscopy is used to differentiate between bovine and porcine gelatins, according to Sabi et al. So the first method reviewed, according to Sultana et al., multiplex PCR method is used to differentiate between eukaryotic fish and bovine and porcine as the control sample. And the next method also used multiplex PCR with restriction fragment length polymorphism RFLP with differentiation between bovine, porcine, and fish gelatin, also according to Sultana et al. And lastly, according to Hassan et al., FTIR with CFACS method is used for differentiation between bovine, porcine, and fish gelatin. For chicken, the first one, alkaline pretreatment, is used by Eric and Sorba. Sabon et al. Also used alkaline pretreatment to extract the gelatin from the chicken. And lastly, Mrazek et al. Used proteolytic enzyme named Polarzim for the pretreatment of the chicken skin gelatin, which is non-toxic. For goat and sheep, according to Harhab et al., acid pretreatment is used to extract gelatin from the goat. and Yahdiana et al. Also used acid pretreatment to extract gelatin from goat. According to Vidal et al., alkaline pretreatment is used to extract gelatin from lamb, and similar characteristics with bovine gelatin are found from goats as both are land mammals. And lastly, for snail, according to Indra et al., alkaline pretreatment is used, and non-reducing and non-reducing gel electrophoresis with STSPH is used for the identification method. Second one, according to ZAHARI et al., alkaline pretreatment is used for extraction, and FTIR method is used for identification. Lastly, according to Gaspar Pintiliescu et al., acid and enzyme pepsin pretreatment are used in comparison and compared with a commercial pigskin gelatin for the results of the extraction. For the next subtopic, food products that involve gelatin include confectionery products, dietary supplements, cake, animal feed, and food packaging. For confectionery products, according to Tukiran et al., ELISA using immunogen of collagen A2I chain is used for the identification method. According to Sultana et al., novel multiplex PCR assay is used for identification method. Lastly, according to Omar et al., porcine-specific short amplicon size for conventional PCR assay is used for identification. For dietary supplements, the identification methods used are specific PCR assay, species-specific duplex PCR assay, and novel multiplex quantitative PCR or qPCR. For cakes, according to Norakia et al., PCR and gene chip southern hybridization is used in muffin. Sanchez used gelatin to study the effects usage on texture of cake in pound cake. And lastly, according to Moen et al., conventional PCR and porcine gene chip Olipro is used in muffin. In animal feed, gelatin is used in the production of pet kibbles, and it is some of the common ingredients used to produce dry pet food. It acts as a binding agent to assist in sticking the feed together and enhancing the palatability. And lastly, gelatin is recommended to be a replacement for starch to help bind the food together and fix the loss of starch. For food packaging, the physicochemical, antioxidant and antibacterial properties of blood orange pill pectin film combined with fish gelatin of different ratios was done with Juridi et al. Issue of synthetic food packaging materials like polyamide and polyethylene that can contribute to ecological problems and health risks were the reasons of the study. Overall, the blend films showed positive results in being a composite film for food packaging as seen based on its thermal, mechanical and structural analysis. In chilled storage, biological activities of the composite film had improved the microbial stability of cheese and was found to promote health benefits for consumers by acting as a barrier against bacteria. Lastly, the properties of halal gelatin that I have covered in this review paper are bloom strength, turbidity, amino acid composition, and viscosity. Bloom strength is a measure of the gelatin's strength and stiffness, indicating the average molecular weight of its constituents, and is typically between 30 and 300 bloom. Bloom values of 220 to 300 indicates a greater gelatin strength, whereas bloom value of less than 150 is indicated low and indicates weaker gelatin strength. It is measured using texture analyzer, and it was found that chicken gelatin has the highest bloom value according to Saban et al. And Tumerkan et al. For turbidity, a research regarding the turbidity was done aiming to determine the rheological, physicochemical and surface active properties of gelatin extracted from big eye tuna, Tunus obesus skin waste. Turbidity of the fish gelatin was compared with bovine gelatin. Bovine gelatin was prepared in the laboratory. The turbidity of the solution was measured by preparing gelatin solution 6.7% weight over volume using double distilled water. It was found that the turbidity of the fish skin and bovine gelatin were 0.25 and 1.21 respectively. Amino acid compositions, according to Sabon et al., and bovine gelatin comparison was done, and results showed that the glycine content was high with 33.70% and 37.05% for chicken skin and bovine gelatin respectively. Amino acid pro and hydroxyproline. Chicken skin gelatin had higher levels with values of 13.42% and 12.13% respectively, whereas for bovine is 12.66% and 10.67% respectively. Next, according to Sabon et al., chicken skin hydrolysate is used and a high amount of hydrophobic amino acids, glycine, alanine, proline and tyrosine were found. Lastly, according to Siragar and Supraitno, fish skin samples from Aphinophilus was used to extract gelatin to study the amino acid content to be analysed using UPLC. This amino acid contained in the fish gelatin is glycine, followed by proline, alanine and arginine. Lastly, viscosity. The gelatin's viscosity is analysed by the time taken for the gelatin solution to pass through a calibrated viscosity pipette to Emerson 1997. One of the most important traits to consider in choosing or developing a gelatin. According to Sabon et al., chicken skin gelatin had a relatively higher viscosity of 150 ml per gram and 127 ml per gram for bovine gelatin. Next, according to Siragar and Supraitno, the viscosities measured for bovine skin gelatin and goat skin gelatin were 53.4 mPa and 49.6 mPa respectively. Bovine skin gelatin is assumed to have shorter peptide bonds but high concentrations of hydrolyzed collagen. Thus, the goat skin gelatin was thought to have a lower amount of hydrolyzed collagen, even though the peptide bonds are longer. And lastly, according to Mohammed Nezhat and Farmani, the analysis recorded a viscosity of 22.71 plus minus 0.04 for chicken skin gelatin and 21.75 plus minus 0.04 for bovine gelatin. Finally, suggestions and recommendations. In conclusion, this review has disclosed the sources of halal gelatin that are used in the food industry, which include bovine, fish, chicken, goat or sheep, and snail. These gelatins are mostly extracted from its byproducts such as the skins and bones. Gelatins are widely used in the making of food products such as confectionery products, dietary supplements, cakes and pastries, animal feed, and food packaging. It is important to study the rheological, physicochemical, and functional properties of the gelatin, such as the bloom strength, turbidity, amino acid compositions, and viscosity. It was found that the chicken gelatin has the highest bloom value and viscosity, whereas bovine gelatin has the greatest turbidity. The most common amino acid compositions that are found in high concentrations in most animal gelatins are glycine, proline, hydroxyproline, and alanine. These characteristics play a big role in setting the quality of the gelatin being produced and determining the desired attributes of the end product. However, more studies regarding halal gelatin in terms of the extraction method, characterization, and processing should be done in order to achieve the desired quality of different food products using different types of available halal gelatin. The more consumers need to have more knowledge on the halal products and their right as consumers. Thanks for watching.